As the world craves more energy, we're now looking to offshore wind to fuel our needs. But have you ever wondered how we harness the power of wind without impacting seabirds that are traversing the oceans? Aspen Ellis joins us today to explain how we can do this.
Some of the unique things about seabirds are that they're sort of defined as being species that forage on the open seawater and can be traveling at sea great distances, sometimes for years, without returning to land. But they are tied to these typically island nesting habitats for breeding. So these species are hugely dispersed and across gigantic ocean basins, are then often concentrated in these very constrained remote island breeding colonies. And a lot of that's because these tend to be predator-free and therefore safer for the birds to raise their chicks. And because these breeding locations are relatively easy to study, you can go to these land sites and answer a lot of questions about the ocean generally. So we a lot of times say that seabirds act as indicators for the marine ecosystem. They're a great way of studying, for example, changes in forage fish abundance or changes just generally in the well-being of those populations. And the questions you can then ask can be things about what's happening in their environment. And it's a really cool concept you'll run into a bunch in ecology where you can study one thing to learn about another. And seabirds are also really interesting in that many species have really broad non-breeding ranges and really constrained breeding site requirements. And that actually means that they're really vulnerable to a lot of human threats. So that includes factors like fisheries bycatch or the accidental catch of adults in fishing nets or fishing lines. Can also include invasive predation at breeding colonies. So when cats, rats, mice, etc. get onto island breeding colonies, they can really take advantage of these ground nesting seabirds and destroy eggs and chicks and even adults. Invasive predation is a huge issue for a lot of seabirds.
Nearly every form of life is facing challenges as humans impinge on their habitats. Let's take a look at just a few seabirds to see what they're up against.
Habitat losses, climate change, and human development. So for example, a lot of these really low-lying breeding colonies on island atolls are really affected by sea level rise because a lot of these birds are nesting maybe 1 or 2 feet above the sea level. So it's a really interesting question in terms of conservation, of how we respond to these impacts, especially as the world is changing, and how much human management needs to play into keeping these populations alive, and if you can actually sustain many of these populations without ongoing management. And seabirds are sort of uniquely challenged in that they're geographically constrained to breed on these predator-free islands, so they can't move in response to changing conditions brought on by warming temperatures, for example. They're also demographically constrained to slow life histories, so species like these albatross live up into their 60s and only produce 1 chick every year or so. So we're looking at a very slow rate of evolutionary adaptation to climate change there, and also a very low return rate from factors like increased adult mortality because of fisheries bycatch, for example. And then they're also finally physiologically constrained to be able to thermoregulate while foraging in seawater and then also breeding on land. So these species that are often foraging in the Arctic are then stuck on these open cliff faces in the blaring sun during the summer as they're raising their chicks. And as we get heat waves throughout the state of California, for example, you'll see birds actually fainting because of the heat waves on their nests, or just have to abandon the colony sort of in these masses when it gets too hot to actually be able to stay on the rock, which leaves their eggs to sort of cook in the sun. Basically, you get really low productivity in those years. Altogether means that seabirds are a really threatened group of species. We're looking at about 20% of historic marine extinctions are comprised of seabird species. About 30 are currently listed on the IUCN Red List, and the majority of populations are experiencing declining trajectories, with current populations reduced up to 70% in some cases, which is truly alarming. So in order to improve conservation outcomes for threatened species, it's really important to find ways to combat climate change. And that's where renewable energy comes in, right?
While the world desperately needs clean energy, the cost of seabirds can be quite high. How do we strike a balance? Let's look at both sides of the problem.
So offshore wind presents a lot of promise towards addressing climate change. It has lower intermittency than existing renewable energy sources, so it has better production in peak hours. It's also a rapidly advancing technology with construction now possible in a huge number of new areas. So we're now talking about this in ocean basins that we weren't talking about it previously, and especially as we're talking about the issue of moving power from the places where it's being produced to places where it's needed. And for all of those reasons, it's a really rapidly developing industry. Globally, we've got 35 gigawatts of existing capacity, and we're actually looking at an increase by the end of this decade, projected out to 270 gigawatts and 2,000 gigawatts by 2050. We're a little bit concerned about seabirds in particular in part because, like I had talked about before, these are really long-lived species with low reproductive output, which means that any mortality that we're seeing from these facilities would take a long time to replace. And they also have pretty significant overlap spatially with the development zones, especially on the East Coast, where there's a lot of coastal populations of seabirds concentrated around these coastal facilities. And they also spend a lot of time in the zone that is rotor swept. And as we're talking about vulnerability to wind energy, a species is vulnerable if it is exposed to the impact, if it is sensitive to the impact. So it has, for example, a flight height that means that it would be sensitive to getting hit by a turbine blade. And then especially sensitive if its population is already not doing well. And as we're talking about impacts, you can have birds that are moving their migratory pathways away from where they already would be, which can kind of increase energy budgets if you have to fly farther than you would before. And displacement also because it may mean that key foraging areas for those species are no longer usable. And then also direct mortality due to collision. And we're really concerned about both of those impacts, mostly on a cumulative scale. While the individual impacts of each facility may be minor, in many regions, seabirds could be interacting with a lot of these things. And this offshore wind energy development is going to be happening so rapidly that we might not have the data we need to actually be able to get refined impact assessments before those facilities are actually put in place. So we somehow need to ensure that we can make this development happen while also ensuring that it doesn't take a massive and sort of planned toll on marine bird populations and on wildlife more generally.
Solutions that accommodate conservation while satisfying our energy needs will require innovation, science, careful planning, and funding. It's a tall order.
Here we're talking about the idea of impact mitigation, and this is typically done through a mitigation hierarchy, and here's sort of a classic graphic of that. This baseline here is what the level of impact would be on any population sort of under a no development scenario. So let's just think about this in the context of like a seabird population without renewable energy. This is like baseline. And then you could think about you constructing a whole bunch of offshore wind energy, what the impact to that seabird population would be under a no mitigation scenario. So we're not trying to do anything to reduce impacts, we're just going for it. And then you build out 3 sort of steps of mitigation to get to ideally a point of no net loss, so no impact to populations, or net positive. So you want to avoid, minimize, and then compensate or offset for impacts. So that first step of avoidance is where we're trying to avoid impacts from happening altogether. And that's primarily done around siting. And here you want to just avoid putting these facilities where there's a lot of wildlife. So we recognize that there's economic demands on where these facilities can be, and those in reality are going to rise to the top of any of these conversations. There's also technological demands about, for example, on the Pacific coast, where you can and can't put these facilities based on water depth or where transmission cables can be run, for example. And then also societal demands. So things like fisheries, use of space are really going to matter for siting, and those may weigh out above avoiding marine bird impacts. And then also just generally, if you're trying to find like a perfect place to put these, you have to recognize that species use the space differently. So there's no likely one perfect area. So then once you have cited to the best of your ability to mitigate all impacts, you want to minimize or move on to your next step. And here we've got a number of different approaches that people have suggested to do this. And those are things like picking layouts of these facilities, so where the turbines are in relation to each other. There's audio or visual deterrence you can do to make the turbines more visible. If you just like paint one of the blades black, it might reduce collision rates for storks. There's also curtailment, or like when you have really dense movements of birds moving through facilities, you can actually stop the turbines from operating, and that happens sometimes onshore. So again, each of these have some limitations and aren't going to be able to reduce impact entirely. And the feasibility of some of these things is also in question. So now what we need to do is, if we can't stop more impact from happening, we need to somehow offset the impact that we can't prevent. And this is what we call compensation or offsetting. So here we're talking about funding the mitigation of alternate impacts to offset impact that you can't prevent at wind energy sites. So for seabirds, you could do things like use money from the new renewable energy facilities to move seabird breeding colonies that are in peril. You could actually move that seabird breeding colony to a higher island, a more biosecure area. You can also fund eradications of invasive species on island breeding colonies. And there's also tools you can do, like funding alterations to fisheries behavior or fisheries gear to reduce bycatch at sea and actively reduce adult mortality. If we want to be able to do this, we need to work with existing policymakers, industry, and government to demonstrate that this would work and show that it's a cost-effective way of doing this, and then actually put in policies that incentivize or require facilities to actually pay into some kind of fund that produces these conservation goals for seabirds elsewhere. So coming back to talking about these long-term seabird monitoring data sets, what we can do is to actually model how much additional impact you would get when the facilities are developed, and then compare that to different conservation management scenarios. We need to figure out how we can actually do conservation where it would be most effective.
If we act now, and there certainly is a sense of urgency with looming deadlines, then we can certainly have a future where wind energy and seabird conservation can coexist.
To actually push new regulations that make management easier to do.